Thank you. Thank you. It's not working. Check, check. Okay, thank you. Thank you. Really good to see you in face in here. Today, actually, LG Electronics, we are going to propose a new project, new open source project, the Timpani. So before that, I explained myself, DK Jung, the VP Engineering from LG Electronics. I'm actually the big fan of the open source. Okay, so actually before the show, I really actually would like to sincerely thank the Eclipse management and leadership for enabling successfully SDV event in Korea at the last of the year. The event had a strong impact across the Korean automotive ecosystem, significantly raising awareness of open source SDV technology. The many local Korea partners, the company expressed clear alignment and showed the willingness to collaboratively build an open source based the SDV platform. So major industry players show substantial interest in participating as well. And in addition, LG Electronics has been selected as the anchor company to lead the government-driven open source SDV standard platform, just like S-Core in Korea. So this momentum now forms the foundation of how we will align the Korea SDV effort with the global Eclipse SDV ecosystem. Thank you. Yeah. So we believe the building a separate open source platform in isolation is not good. So in particular, you want to avoid the fragmentation with the existing Eclipse project like S-Core. So instead of that, LG Electronics aims to play a bridging role, leading the Korean standard while collaborating with a project like the S-Core, SDV Eclipse, to create some synergy rather than some isolation. Okay, this is brief, just introduction. So now actually talking about the today topic, the Timpani. So we proposed a new project, the Timpani.
You should change the pages.
Oh, sorry.
Yeah.
I'm sorry. Yeah. So Timpani. So we're talking about the Timpani briefly. Okay. So I believe that the future SDV system must satisfy some combined set of the requirement across safety, critical, autonomous driving, and rapidly evolving AI capabilities. So that means that the ADAS, AD plus the cockpit AI all together. So the AD, autonomous driving demands strict safety, some robustness, and increasingly continuous update, maintain model accuracy and regulatory compliance. In cockpit AI interaction, on the other hand, require high flexibility and fast iteration to improve user experience and intent understanding. These two domains now operate as a single interdependent workflow. So we believe that the real-time coordination between the safety critical perception and planning and adaptive AI agent is becoming more essential. So as a result, SDV platform must evolve from tightly coupled and the rigid architecture to system that maintain strong safety guarantee while supporting the flexibility and update velocity required in especially the AI automotive area. I'm sorry. Oh, no. So specifically level 3, more than that, the AD definitely a failed operational architecture becomes a critical design goal. To achieve this, the vehicle must adopt a multi-ECU and multi-SoC architecture. So enabling this system to continue to operating safely even when the one computer unit fails. This shift means that the traditional design where each ECU or SoC operatively independently is no longer sufficient. Instead of that, a distributed architecture with clear fallback and takeover passes is required. And this kind of a requirement, a new software level mechanism for coordination and monitoring and system level management. Simply saying, the L3 or more than that, the AD requires transition from some isolated compute node to coordinate the multi-SoC and multi-ECU system with the built-in fail operational capability. So to meet the SDV requirement, safety critical behavior, the real-time guarantee, the continuous update and the fail operation continuity, we can break the orchestration, break down the orchestration into two pieces of technical dimension. One for the spatial, and the other one is the temporal. So the spatial perspective of orchestration determines where actually workload run. So distributing and migrating tasks across the multi-SoC, multi-ECU system to maintain the fail operational continuity on the failure of overload. That means that, for example, just some resource is not available. It's actually the uploading to the some available the ECU or cloud. So that's the spatial orchestration. So, and next door is temporal orchestration. Determines that when workload run. So this is enforcing the real-time deterministic execution, so that safety critical function remain protected even as AI workload evolve and fluctuate. So altogether, these two forms of orchestration, the spatial plus temporal, provide the foundation of SDV platform that must remain safe and real-time, continuously update, and resilient in dynamic runtime environment. So we already just contribute the full PD project. So the full PD provides the spatial orchestration. It allocates the constraint, the compute resource required by each workload, and manage the resource isolation, and performs workload placement and migration across the multi-ECU and multi-SoC. Through this full PD create a stable and controllable execution, the environment where workload can run reliably, even under dynamic resource condition. The Timpani provides the temporal orchestration. It coordinates the execution schedule across the workload running on different SoC and ECU. So maintaining a global aligned time plane. So maybe you can think about the multiple ECU environment. So definitely just to synchronize the whole bunch of global timing across the relative ECU side. So by continuously monitoring execution behavior and timing constraint, Timpani collaborate the full PD to trigger fallback or takeover action, forming the software basis for fail operational behavior in a distributed system. Just to using together, full PD Timpani delivers system-level orchestration across space and timing-wise, enabling the platform to meet the SDV requirement introduced earlier. So traditional big system rely on the single load, the locally deterministic schedule. On the other hand, the SDV platform now operates across the multiple load, requiring global time alignment to maintain consistent and predictable behavior. So to address this, we proposed the new open source project, Timpani, that provides global time-based deterministic schedule across distributed node. So use case actually very simple. The cost optimization is so important. So we definitely consolidate the multiple ECU, but at the same time, there are thinking about some real use case like a real AD and the cockpit inside together. So I think that this kind of technology really just give a good, the advantage for that. So the technology-wise, my colleague, the Chulhee, actually he will cover the detail and also some demo. Thank you so much.
Okay. Hello, guys. Yeah, very nervous. Yeah. Thank you for introduction. By DK. My name is Chulhee Lee. I'm the principal, research engineer, in the CTO division at the LG Electronics. Actually, already DK mentioned, within the LG Electronics, I'm a PPT project leader, and the Timpani also, I'm leading the Timpani project. Within the LG Electronics, I lead the development of the in-vehicle orchestration layer for the SDV platform. So our focus is building a runtime architecture that combines real-time scheduling and mixed criticality control, and also the distributed workload orchestration across the multiple issues. Two core projects, the Timpani and the PPT, we are contributing both of the projects to the Eclipse community as the open collaboration initiatives. Today, I will introduce the new project, the name as the Timpani project. Okay. Now, let me briefly explain the Timpani architecture. Actually delivers global time-based scheduling across multiple issues. There are three issues in this model. Each issue runs as the Timpani N, each Timpani N, something like the Timpani node, and which connects a local scheduler and on the eBPF, based monitoring layers on top of the Linux layer. This node execute workloads according to a shared global timeline and report execution status back to the orchestrator, the layers. That name is the Timpani O. Timpani O means that Timpani orchestrator. So at the top of the system, we have the Timpani O, the orchestration layer that distributes the global execution order and collect the timing information from each distributed node. This allows the entire vehicle to follow a coherent and the deterministic execution, something like the rhythm, even when workloads span multiple issues. All load communicates over the Ethernet or the TSN. Actually, in my opinion, we recommend by using the TSN, ensuring the low latency synchronization and enabling scalable multi-node integration. And then the Timpani manages the timing at the container level. It becomes much easier to introduce the new workloads or update existing without breaking deterministic behavior from the execution frameworks. And the eBPF-based monitoring built into each node gives us the continuous visibility into the timing constraint and execution delays and potential violations, such as providing the information needed for the PPT to react or trigger the fallback scenarios when required. In short, this architecture provides a scalable multi-node foundation for the deterministic scheduling in the SDV systems. Okay. Next, as I mentioned before, I'm the PPT project leader and also the Timpani project leader. So we thought when we think about the Timpani and the PPT, we thought we need to make the two projects and we need to make the collaboration each others. So I'm going to speak how PPT and Timpani operate together as the coordinated orchestration layer for the SDV platforms. PPT handles spatial orchestration, deciding where container workloads run across the issues. And the Timpani handles temporal orchestration, determining when they execute and ensuring deterministic timing behavior. Each runs a Timpani end node with the EBPF, the monitoring layer. It continuously observes execution timing and reports the deadline miss or deadline violation or the abnormal patterns to Timpani O. When a timing violation or when the deadline miss is detected, Timpani immediately reports to the pulpit, and pulpit performs system-level the orchestration action, something like actions, the reallocating resources or the migrating workloads to the another issues or the cloud also, or the activating of fallback scenarios by predefined the scenarios. This enables deadline-aware scheduling with the system-level fallback, combining the temporal enforcement with the distributed recovery. Beyond the fault handling, pulpit also adapts to operational scenarios. When driving context or the workload pressure changes, it adjusts workload placement and priorities across issues, while Timpani enforces the updated timing models. This provides the scenario-based orchestration across the vehicles. At the high level, this system is policy-driven. The pulpit defines runtime policies, such as the target FPS or the latency bounds, and dynamically adjust criticality levels. Timpani translates those policy decisions into the deterministic scheduling behavior. This creates something like the policy-driven mixed criticality, the runtime control. The pulpit and Timpani combine spatial control and temporal determinism and policy-based criticality management into a unified orchestration layer. Oh, we have the 10 minutes, yeah. On this slide, I'd like to explain how pulpit and Timpani actually communicate with each other inside the system. But we don't have enough time, so I think it's better to skip there. Yeah, you can check our slide after the event. Yeah, it's better. Okay, it's better to show the demo. I'd like to show the simple demo about the collaboration of the pulpit and Timpani. Before we move on the real demo video, let me briefly explain what you are to see. For this demo, we implemented perception algorithms using the execution order frameworks and packaged it as a containerized application. This container is then scheduled and monitored by the Timpani, which provide deterministic and control level execution timing. To demonstrate how the system reacts under timing pressure, we intentionally push the perception workload into something like the deadline status. Timpani check the execution timing of every frame, the FPS, and whenever a frame exceeds its defined limit, we define the 30 FPS. In that case, the deadline miss counter is increments. For this demo, the threshold is set to the 15 deadline misses count. We originally tried much lower level, something like the 5 or the 3, the count of 3. In that case, actually no one realized that changed. So it's not demo, just to show, yeah. So the 15 gives us a clear and observable behavior. Yeah, it's better. And importantly, this threshold is fully declarative, the architecture, meaning that it can be adjusted to any value depend on your requirement or the workload characteristics or the safety strategies. So now let me explain the graphs. At the top graphs, the pink bars represent the CPU cores running the perception algorithms, and the blue bar show the other workloads sharing the CPUs. the middle graph displays the FPS changes, something like the latencies, and the bottoms, the graph, something like the deadline miss counter. So yeah, I think it's better. Yeah. So okay, let's see. So let me show the demo video. On the left, you will see the perception output, the running inside the container, and there are the dashboards showing the FPS and the latency and the CPU allocation and deadline miss counter. So you can see, okay, you can check the deadline miss counters and the CPU cores, what could be changed. Yeah. It runs. OK, thank you. The stressed status, deadline count, checked, and immediately changed the locations for the perception algorithms. So, and then you can check the FPS is the going to the normal state from the very high pressure status. OK. As the final update, I'd like to briefly share the current status of the Timpani project. The Timpani is now fully prepared for the open contribution. Actually, it's already uploaded on our project, the MCU DAS, the Piccolo. So Timpani, so although the core components, the time trigger with the monitoring logics and the sample applications are already organized and publicly available on the GitHub. The architecture has been validated and the repository is ready. At this point, the only remaining step is something like the Eclipse project proposal process, and then I think we can one of the Eclipse projects. Yeah. So in the short, the development is ready and the repository is also open. And as soon as it's possible, the Timpani will be the one of the Eclipse SDV projects. OK, thank you very much for your time and the attention. Thank you.
Thank you. Thank you, Chulhee. Thank you, DK. It's an honor having you here. So is there any question?
Oh, yeah.
Oh, there. Who has the microphone? OK. Good, thank you. There. I think, OK. Well, the order is decided.
My question would go in the direction, as you say, it's for level 3, level 4 autonomous driving, and you talk about fail operational. Where are you actually running then your Pulpiri and other parts on top? So is it, which operating system is underneath, and do you run multiple instances to come to a more predictable environment? So,
yeah, good questions. So actually, usually we think about the AD or the autonomous driving systems could running on the RTOS, such as the QNX or the others. So in that case, we need to think about it's possible the AD and ADAS algorithms running on such as the Linux, the RichOS. So it's possible. So basically, there are several the use case or the validation based on the Linux layer for the autonomous driving. And also as you know, the Automotive Foundation. Do you know that Automotive Foundation? They try to something like the decomposition from the safety critical. For example, the control modules and the perception and the algorithms also. And also, if we think about the E2E driving or the VLA based autonomous driving, in that case, it's usually we can think about the Linux layer. It's possible. So basically, the Timpani and the Pulpiri project is based on the Linux layer, but we think about it's based on the centralized architecture. So in that case, we can cannot control the RTOS, the function, for example, the thread X or the others. It's not possible, but it's possible to gather the metrics or the monitor data. So and then we can control the Linux layer, the workload for meeting the determinisms. So that's our concept and our ideas for the autonomous driving. Thank you.
Thank you. There's
So
another
if
question.
you're setting up a global schedule across ECUs, do you then have time synchronization with something like GPDP on the network?
Yeah, sure. Basically in the tasks we have several colleagues they in charge of the networks and the ENE architecture and the HPC also. So we can try and we can validate based on the TSN, the technology, the network stacks, and then we already validated everything. Yeah.
There's one last question from Ansgar.
So I wanted to make one comment, or first of all, I wanted to really thank you guys because DK was just explaining to me you were flying in for this event from Korea just to give that presentation. So we really highly appreciate your effort doing that. And then I just wanted to comment that from my point of view, it's really interesting to see how also Korea as a country and the automotive industry is building more and more on open source. I'm really happy to see also what you are playing as a role, so appreciate it. I just want to also give the community a comment on that because we've been striving for international growth last year. We are already seeing international growth, and I cannot talk about it yet, but we are having some good news from Korea soon in terms of community growth. So we also need to, and that is something the team on the Eclipse Foundation side is already having on the agenda, we also need to think, okay, how do we work with these international communities, bridging time zone gaps, language gaps, etc. So that is something I'm already asking the projects to also think about how to deal with each other, how to overcome these things. And we are already having ideas also to help that. So interesting development. I really love to see that. And I have one question to the project decision as well. It's more how was the design process? Because I bet you maybe also thought about integrating that technology into the Pulpery project instead of doing it as a separate project. Mm-hmm. And I'm interested about what was the thought processes. Why did you put it into a separate project? Maybe you can talk about it.
Yeah, it's very, very great questions. Actually, when I think about how to make the orchestration layer, in that case, I thought there are a lot of the possible and the candidates, the solutions, will be occur, like the NKIOS and the Bluetooth also. So we thought about we actually as a tier one, we need to make something like integration, the projects, but we would like to make some the specific functionality also. So we thought we need to prepare something like the microservice architecture for our solutions. So Pulpery and Timpani, and also they have their own microservice architecture inside their project. And also we thought the Timpani and the Pulpery also one of the microservice architecture for that. Yeah. Thank you.
Thank you. Thank you so much for being here. Thank you.